Okay, I'm just gonna slowly start. So yeah, welcome to the next Firecracker team learning session. This time I will be talking about systemd units and maybe a few other things that are happening on the node. And I wanna okay, I'm gonna go, this is a summary, so I'm gonna go first about a little bit about the node provisioning and ignition and how actually the systemd units get into the node first. Really quick recap what systemd is, if nobody has no idea. I want to go over all the interesting systemd services that are on the node. There will be demo when I'll be running on the node and showing few things, a few maybe tips and tricks, I don't know, and then question runs. And in general, if you have questions about anything that's on the slide or I'm doing, it's probably better if you ask right away than leave it at the end. Okay, let's start. So node provisioning and ignition. I assume everybody heard about ignition before. It's a way how we deliver or configure the node for all the giant swarm nodes. Usually it works the way that, can you actually see my mouse? No?
No, I don't.
Pointer. Can you see pointer?
Now we can, yes.
All right.
Yeah.
So it starts at the provider operator. It can be AWS, KVM, or Azure. That doesn't matter. It will see that there's some cluster created. It doesn't have to be created. It can be updated, whatever. It usually just reconciles all the time, and it will generate ignition. That ignition is uploaded usually to some kind of storage. In AWS case, it's S3. In Azure, it's Azure Storage. In KVM, it's stored as config map. And then there's some kind of delivery system that delivers it on the node. On AWS, the node is started with definition of the URL of the ignition. So when it's booting, it will see, okay, I have this URL, so it will download the ignition and then use it to bootstrap the node. On Azure, it's similar. On KVM, it's done that the config map that's in the control plane is actually mounted to the container and passed to the QEMU when it's booted. As I mentioned, ignition is usually one big file. We use YAML for defining it. Most of the template that we use is the K8s cloud config repository, and we define it in YAML. But one interesting thing that when we pass it to machine, it's usually in JSON. It's so we can remove all the white spaces and all the things. It's not really readable, so it's better to work with the YAML at that point. Ignition is fetched in really early boot. There are actually two phases of the ignition. One is super early, and it's creating disks and creating file systems and these things that before the whole system actually boots. And the second part when it starts creating files, systemd units, and other configuration files. Important thing to know is the execution happens only once. Usually the image that we have in the cloud has a flag or something like that that say, okay, you should execute the ignition. And when it's done, then you can do whatever with the node. It's not gonna to be executed again. So if you change something that was created by the ignition and you're gonna reboot the machine, then the file is gonna stay. There is a way how you can enable the retriggering of the ignition. If you create special files or boot the kernel with special arguments, but you should, in normal cases, that should not be done. Shouldn't be doing that. So I prepared here just a simple ignition file to a little bit describe how it actually looks. At the start, the ignition, we define the version because different version can have different formats, so the CoreOS know what's happening. Then there's a section with the users, and we defined, for example, our giant swarm user, the groups in it, and maybe SSH key. This is truncated, so it's not that long. Then there's a section for the systemd units. You define usually the name, the path, where it's going to be, and some content, and yeah, other things. There are other, as I mentioned, there are other sections that's for disks, that's for file systems and other things. And this is one big file that's then sent to the machine, and it's just go through it and do all the steps. Any questions so far? Am I going maybe too fast, or if it's okay?
I'm good.
Okay. All right. Then let's go a little bit. So systemd. not going to say any further, any really deep. Systemd, just you know what it means. For us, it's basically unified service. It unifies the service configuration across the Linux distribution. For us, it's the system and service manager. So it's the way how we manage the services on the node. Service, it's just basically binary that's meant to be running for a long time or like all the time. It helps us to bootstrap the user space and manage the process. So you can define when you start a service, you can define maybe which user is going to run, which the directory, what should be the steps to do before start of the service, before what steps should be done after it stopped, and things around that. Maybe some dependencies when it should be actually run as well. Uh, Here's when we talk about systemd unit, this is exactly the file or the text that we are talking about. So it's the definition of the service, which is usually located, as you can see here, an ATC systemd system on the node. Some of the services are located in different folders, but they're usually system services and not really that important, mostly not important for our work. So here it's ATCD free service. It's a little bit truncated, so it fits on the page. Some of the things that we use are not here, but it's not important. Each unit has like several sections. There's a unit sections where we describe the unit itself. There can be some long text describing what the unit actually doing. Then there's the dependency configuration. We see that now this unit requires and can be run only when these services are running. In case some of these services is not running, maybe it failed, then this service would not start as well. You could see that maybe sometimes in the logs that it says the unit, the dependency failed for this unit or something like that. That means that one of these units that needs to be started maybe failed or is not running, so this unit cannot be started as well. Then there's a conflict. That means that if these units are running, then the etcd-free cannot start. The main part is the service, where we define how the service should run, what are the limitations, what are the user space, and how it should behave in general. There's lots of configuration. That's not going through all of that. Important part usually does exit start. That means what's going to be executed when the unit start, and there's exit stop as well. And then can be some exit start pre. That means it will be executed before starting the unit. It can be exit start post. That will be like after it's done it, but it's really specific to something. The last part, I hope you can see it, not because it's the install part that's somewhere here, and it's defining when the unit should be started in which environment or what are the conditions. Most of the case, it's going to be multi-user because that's the default unit level that we run on the Linux. On your computer, it could be, for example, graphical interface. So it's a unit that will be started only if there's graphical interface on the server or on the machine. Okay, so let's go to the actual joins for things that we use. So some that's not full list, obviously. That's I would say the most interesting units that we have running on the nodes. I will try go some of them when into demo as well. I'm just gonna here try to explain what each of the units do, or maybe some interesting things about them. So the first three, the dot in yellow, that runs only on the master. This is actually even lots of AWS specific things. So some Azure or KVM specific units may be missing here. etcd-free, it's I would say self-explanatory. It's a service that's running the etcd that we need for our KH API. etcd-free attached dependencies, that's a little bit newer unit that we introduced with running the masters in ASG in AWS. It's necessary there because of some reasons, but what it's actually do, it's mounting the volume, the storage, and the network interface for the etcd. There can be some corner cases when the etcd-free is actually running, but the etcd-free somehow attached dependency failed, and it's showing some error. So if the etcd is misbehaving or doing really bad, makes sense to take a look at the unit as well to see if there's maybe anything wrong with that. The third one is K8 agent. That's unit that's bootstrapping the whole cluster with the core, let's say core components. It's usually installing the CNI, it's installing airbag policies, it's installing some basic network policies, it's labeling the namespaces. It's basically all the things that needs to be done before we can install anything on the cluster. It's this unit can sometimes fail, so it's useful to check the logs, what's happening there. Next one is K8 setup network environment. That's early unit that's used for creating some configuration files, specifically network environment files for the kubelet usually, but other services use it as well. It check the IP addresses on the server and then create a file with IP addresses that used later. K8 kubelet, and that's I would say explanatory as well. It's the main service for running the kubelet. Now it's actually running only the binary, the Docker, the container version. It's already gone in the latest versions. K8's label node, it's labeling the kubelet after it started. The reason for this is that some of the labels can be set during the boot up of the kubelet in the configuration, but only like few domains are allowed and the rest has to be applied on the node afterwards. It's a joint API. K8's extract, that's one of the new unit as well. It doesn't load the hypercube image. Well, at least for now. I think in the new version it's also going to be different. For now, it's definitely the hypercube image, and it's extracting the binaries for the kubelet and kubectl, and I copy them right onto the server so they can be used in the specific units. Wait for domains. That's a service we introduced a long time ago. And we had some issue with the DNS that the node was starting before API DNS or ATCD DNS was still not resolvable, and it caused lots of race condition and problems. So the wait for domains is usually one of the first units that needs to be executed properly before anything else can start. It's ensuring like the base DNS. It's checking API, etcd, but it also trying to resolve some outside domain to ensure that like the full DNS services is in place. I would say these were the most interesting, something also the one that most often fails because of some reasons. So you're usually going to work with them. Then there are a few others that maybe they're happening, but usually there isn't that much issue with them or they are not that important. At least mostly they are running fine. So decrypt K assets and decrypt TLS assets, that's AWS specific. And the first one is decrypting. One important thing is that the certificates and private keys in the ignition for AWS are fully encrypted. I think in KVM that's not the case. On Azure, I'm not certain. I would say they are also not encrypted. Christian, you remember that?
They are encrypted.
They are encrypted. So you have like similar decryption unit as well.
Yes.
Okay. Yeah. Okay. All right. So that's going to be similar on AWS and Azure as well. So yeah, after creating this encrypted file from ignition, this unit is going to decrypt them so they can be used. The first one is for private key that's used for encrypting the ATCD, because the Kubernetes API, when it's storing the data into ATCD, it uses this key to encrypt the data, so it's not in plain text. And the second one is for decrypting those certificates for API, ATCD, kubelet, and anything that's run on the service. Then we have two services, K8 setup kubelet config and K8 setup kubelet environment. These are necessary because the configuration files for the kubelet has to usually change depending on what machine it's running. We need like some specific IP for the setup for the kubelet. We also need setup on AWS the amount of max pods because of the limitation of AWS CNI and these configuration like this. So these are executed before the kubelet and they template the files so they have the right values before it starts. Then we have also it's not systemd unit, it's more like a mount unit. that we use also, that are used for mounting volumes like varlib docker, varlib kubelet, var lock, and it's just specifying what should be mounted where. Yeah, lately this just in early days these were failing also because of some things, but I think lately it's fine, it's working, so you should not encounter a problem with that as well. They are executed very early at the phase, so if anything like that fail, mostly everything else will fail as well. Then we have set hostname service. On AWS, the image for some reason it has like the default hostname is not full hostname that needs to be, and we had some issue with the K8s conformance test. So we need to set the hostname properly. We're fetching that from the AWS metadata and set hostname when it boots. OS hardening, that's unit that's configured some let's say deviation from the defaults in the kernel or some configuration on the server or security changes and things like that. And then there's such units like setting a group or owner permissions for the jams phone. I think that's because cert exporter is reading that, and we didn't want to set it as running as root and similar things. Any question to some of these services? Okay, then I guess it's time for a little bit of demo here. During the demo, if you have any questions, please just ask. I'm probably not gonna look if somebody raised hand or anything like that. So I have one cluster that I prepared. It's a testing. What happened? I love it. Okay. So I have a cluster that I prepared on AWS. You can see that there's one node in not ready state. I did some bad things on that, so it will at least something to show up. And a little bit way, at least, to show how I do stuff or how I operate when I see this. So I'm just gonna use the raw obctl ssh to gauss. The cluster is running on gauss. I'm just gonna ssh to master. It will take only a few minutes. Okay, we are here. No, not yet. Okay, I would definitely recommend to pay attention to this. The Flatcar or Chorus have the nice thing that if you log in the machine, it will show you failed units. And if you see one of the units that I was written, so it's like usually there should be nothing. The setup and everything, it's mostly tested, and the unit should not fail. If it fails, something could happen. So definitely pay attention if you log into the node and there's something wrong with the node, you know it, and you see failed units, that should be the first thing you probably investigate. In case you somehow clear it or you don't remember what is there, you can still use systemctl list them easily. You can use command systemctl list units, and you can just grab for failed. Okay, failed. Now you can see that I only have one, but I had three before. The reason for that is that some of these units are restarting, like they are running for some time fine, and then they are like broken again. So if you run it a few times, you can see that there's a difference. Now it's because they're running for a few sites and then failed, and again.
Sorry to interrupt. You can use the -- failed flag without grabbing, which is a little bit more fancier.
I see, you learn something every day. Okay, so you can use apparently like something like that. Okay, now I don't know what to do next. Christian, what should I do next? Now, obviously, if you have failed unit, you'll probably want to know why it failed. So the best way how to do that is check the logs.
I knew the answer once.
Okay, so there's nothing here. That's interesting. It can happen. It can happen when maybe the unit failed sometime before and the logs were rotated. So currently now we have no information what happened. But one of the trick that usually works is restart the unit. Let's see if that's going to do anything or not. Okay, it's failed again. Let's see. Okay, so I restarted again, so it's flashed the new logs, and now I can see what's happening now. If somebody not familiar with that, you can just easily scroll with arrow key. So if I push the right arrow key, it will show me the relevant logs and not just the stupid hostname. So here I can see, okay, so there is some bash error, syntax error. Okay, so there's probably something wrong with the unit. Obviously, I did that to have something to extra. Normally, this should not happen, but it can happen if you're testing something new, some new unit or some new changes that you do to your units. You can see this. So what I would do here is now go to the folder, as I mentioned, is atcd system. Here's all the units that we have, and I'm just gonna check the k8 label node service. Obviously, I need sudo environments to do any changes. And I remember that was line 7, which is here, and yeah, there is some error command inserted. It should not be here. It should be like this. So now I'm just gonna try to quest it. And if I do change to any system, the unit file, you cannot just now restart the unit. It's because the daemon is not gonna pick the changes right away. You need to do magic command that's called daemon reload dash like this. If you don't if you don't do it, then you will get warning anyway. If you're just gonna restart it, you see warning. The unit file change on disk. So you should run systemctl daemon reload. So it will actually tells you that you need to do it. Okay, now if I restart it, it hopefully should not fail because I fixed something. But it taking a long time because it probably needs other units as well. Usually, if you're restarting something a unit like that and it takes for like few seconds, doesn't really make sense to continue further because it's probably not gonna happen. Okay, it failed again. But why did it fail? Let's see. Maybe a different reason now. Unable to connect to the server. Okay. Interesting. Just gonna check if the server is actually working or not. Should be. That's a test server, so maybe there's something wrong. Exactly. Come on, come on. Interesting. It's getting hot. I need to take my shirt off. Okay, so this is not going to lead anywhere. Looks like it has actually issues to connecting to API for some reason. So let's check if there's any more failed units that could be caused of this. It's still just this one. Interesting. Okay, so I'm just gonna. Oh no. What's. Okay, no. Okay, so it's actually flopping. So I'm just gonna check if the APIs are alive or. Okay, there's one API that's crash looping. Okay, that's probably the root cause. But why is it crash looping? Nobody knows, right? So I'm just gonna go to the server. I can check the logs, obviously, and even from here. If I just do logs, it's maybe too small for you, don't see it, so I'm just gonna extend it. It's going to time out because the API is not working. Okay, I will go onto the server. That will be faster. So I'm just gonna go. I could check where is it running, but I know because it's the server name is appended after the pod name. I can just do this easily. Now I can check for the logs of the API. As you can see, I use Docker PS. I appended -a. That means include all the pods, even those that are dead, which is kind of useful if the pod crash looping, then it's may not running, and you need to see all of these. And this is the pod I want to take a look on. There's lots of log, but there's still no error message, so I'm really quickly searching for the error message somewhere. Error while parsing encryption provider configuration. So this is the file that's used for the encryption of the etcd. And it's missing kind. So my quick guess is going to be that the file is empty because some of the decryption somehow failed. But let's see. I didn't prepare to this. This is just really wild. I need some
I did.
permission, obviously. You did?
No.
Okay, as you can see,
But
it's
now
empty.
it's interesting. I like it.
Okay, so as I mentioned, that this is the case encryption config, and it's the unit is the decrypt TLSK that's responsible for doing it. So I'm just gonna check that unit now. It's this one. Okay. Oh, okay. Could not connect to the endpoint rule. And yet it succeeded. That's not right. Okay.
Do we have a postmortem for that?
Maybe we need one.
I think we should have one.
Decrypt key assets. Okay, this is one of the units that's not really gonna tell you anything because you need to check the file. So I'm just gonna go here to the file. Okay, so it's a little bit complicated bash, which I don't like, so I'm just gonna go here. So the first that's executed, it's main. Main, it's running KMSK as a decrypt, and then it's doing this. So where is this function? Okay, this is it. Okay, so this should be executed. So Docker image for AWCLI. We pull the Docker image, ensure it does not fail until then. And then we run the decrypt. Okay, I see that there is the fix for it should, when it failed, it should fail. Okay, it's something for maybe postmortem that we need to check out. I'm just gonna go and just gonna restart the unit. I'm pretty sure it's going to work. Well, certain. Oh, come on. Okay, so it failed here, but looks like it didn't fail here. So not this one. Okay, it's not empty anymore. We could theoretically wait until the API is going to restart itself after some backup. I'm just gonna kill it so it's quickly recovering. I'm just gonna kick the kubelet as well. Come on. Okay, API is now running 11 seconds. So I assume it should be fine now. No errors. So I will go back here. I'm just gonna go to the original node. And I'm just gonna hopefully restart the unit and it will work. Yes, amazing. So now if I do systemctl list units, dash failed, there's no failed units.
Bam!
And the kubelet should be now ready. It's not yet ready. Can probably wait a little bit longer. Or we can restart it. Just gonna check the logs as well. So no, there's still some error in the kubelet. And I need to scroll to find the error, which is not always super easy. No, there's a configuration still. Nope. Yet. Okay, failed with the exit code. You can see it's not super easy to find error in all of this. Yep, does not work. So now we have the node in the state that's like a little bit tricky. We know the API is fixed, so everything should be fine. I could probably invest more time to find why is it. My guess would be that some of the units that were supposed to start before the kubelet did not start right. Maybe some of it I would maybe need to restart them, or I could also, in these cases, if we know what was the root cause, but the node is in some weird state, there's also one option that you could terminate the node. Which could, in this case, even if it's not running, it's not really big deal. It's probably going to save you some time, depending. Or if it's on AWS, you shouldn't be that worried about that. I'm just gonna do what's my gut feeling here. I'm just gonna restart a few more units. I'll see if that helps or not. Fine. Okay, what's here?
When you restart now, based on your gut feeling,
Yeah,
is the
because
order important, or is it just that you know that from experience in which order to do what?
I would say from experience, I know these two units needs to be run before the kubelet itself. I could maybe even do like, because I know it's still restarting, so I'm just gonna stop it. So it's going to calm down. I'm just gonna ensure that these two services executed without errors. Fail, but this is hard to read, I would say, but this one didn't exited with code status 0, which is fine. The rest is like it's about when it starts, it ensures that the Docker container is not running, so it's stopping and removing it. So it's not really that big issue if it exited like this. Important here is the main pit exited with 0, so it succeeded the unit itself. So that's what's fine. And what about the second one? It's this one. It's also exited as well, so I'm just gonna restart the kubelet now and see if it maybe help. No, this is something that it does not really like. Which is the next one? Cibelet config. Okay. Not very useful errors, but looks like usually when it shows this helps, it means that the configuration for something is not proper. Could be that something changed during that time when I broke the node, and then why, but it's like super hard to find what's actually wrong for some reason. Yeah, I think I'm at the point that I would probably personally didn't look that much further because I know something broke on the node. I would just terminate it. I would like to find in this session what's actually happening. Started kubelet. Okay. Okay. Whew, you see now. I did that. I completely forgot about it. You can see here, unknown flag enable server xxxx. Took some time, yeah, but that's the.
So you planted 2 Easter eggs and you forgot about one?
I planned only one Easter egg. Like two problems. I forgot about one, and then the API was not planned at all. Okay. So yeah, I did this. So I now.
Wow.
So I find that it was unknown flags enable server blah blah. So now I'm just gonna do the daemon reload again.
So was it just that we did not see the in the logs because it's hard to read, or
Yeah,
why
it's
did
super
you
hard to
do
read.
that?
Basically, if one of the configuration is wrong, it will say this configuration is wrong, and it will print the whole help for the kubelet, which is like 200 pages of options. And then it restarted this again. So then one specific one line, it's hard to find. So now I remove it, and I think this should work. Okay, the kubelet is running now. Okay, yeah, so we can see this is the folder behind. There are all the other units. So we went from the Kate kubelet. I'm just gonna go show what's it here again. It's like this is the unit section, service section we see. You can specify the user, which is running under root. We define some other C groups things, environment variable. And then this is the command for running the kubelet. Set some of the things and install. Yeah, the etcd I already showed as an example. What is next here? The wait for domains. Just gonna give you a quick overview how it actually looks. You can see again, this is like the not readable unit that you need to go to the file. And it looks like that there's 3 DNS. One is from etcd, one is from API, and then we use example.com as well. And we just make sure that all of these domains are resolvable before this is fine. And only when this unit succeeds, the rest units can go on. It's also like a little bit check that the networking is working properly, because in the really early boot, could be that the networking on AWS can be flaky or not working yet. And just for the kubelet configuration units, yeah, this is just is using command env substitute, so it will use the environment values from these files to substitute the template file for the kubelet to the normal one. Just gonna show you how that works as well. This is the kubelet configuration. Here we will just template the IP address. We also template the MAC spot, that's for the ENI limit. And yeah, that's probably all for now. All these configuration files, usually in the etcd Kubernetes folder. And we have here a folder SSL, which is for the certificates. We are all encrypted and non-encrypted. Then there is the config files, which is for the kubelet or proxy kube configs. And then kubeconfig itself, which is for the kubelet. Could be also API or something else, depending on if it's faster or not. Okay, I think I'm just gonna wrap it now here. I think I show a few of the things on the notes. Is there any questions?
Maybe one question from my side. You talked about the ignition in your slides, right?
Yes.
I still get a bit puzzled by like where does the ignition operator jumps in? Does it just like actually do anything on AWS, or is it just like
you mean
not
ignition
really
operator? That's the operator that's like in work in progress.
Mm-hmm.
Okay, so it's not used now. I think the idea here is that instead of AWS operator creating the ignition, it would be ignition operator who see the CR and create the ignition, probably stores it, config map on the AWS, or maybe upload it to the S3, and then just AWS operator would just inject an URL to the node. So we would just like remove this part from the AWS operator, and it could be used. One ignition operator would be basically same for all the providers. So it can make a little bit maybe simplify some of the things.
Got that. Okay, thanks.
Sure. Okay. I just wanted to try if maybe here it's linked to the ignition in the kernel args, but yeah, I think it's not. It's mounted different way. Anyway, then if there are no questions, I'm just gonna stop presenting here, and I'm just gonna. There's no more questions at all. Okay, I'm just gonna stop the recording as well.